All right, let's get into it. Today, we're leveling up from basic integration and learning how to tackle those trickier problems. The ones that can really make a difference. Think of this as adding some serious power tools to your math toolkit.
You've probably been there, right? Staring at an integral and you have absolutely no idea where to even start. It happens to everyone. Well, today we're going to smash through that wall and give you a clear game plan for what to do next.
So here's our roadmap. We'll kick things off with the foundations, then put two powerhouse techniques head to head. After that, we'll build out your mental toolkit so you can spot the right method, and we'll wrap up by building some confidence with actual exam-style questions. Now, further integration sounds intimidating, but it's not about learning a whole new subject. It's all about building on the skills you already have. So let's do a super quick review of the standard integrals that should be second nature by now. First up, the good old cosine of kx. Just remember that k on the inside becomes a 1 over k on the outside when you integrate. And of course, cosine flips to sine. And please, please don't forget the plus c. Next, we've got the exponential function, which is always a welcome sight because it basically stays the same. Just like with cosine, that k in the exponent pops out front as 1 over k. Super straightforward. And rounding out our big three, the integral of 1 over x. This is the special case that gives us the natural log of the absolute value of x. Seriously, these three are the foundation for almost everything else. So, how do we use these in a real problem? Well, let's say we have this equation. First, we just integrate each piece to get our general solution with that plus c hanging on the end. But to find a particular solution, we need more info, like the point pi 8. We just plug those x and y values in, solve for c, and boom, we found the one specific curve we're looking for. Okay, now for the heavy hitters. Sometimes you'll find an integral that can be solved in more than one way. So let's look at a classic matchup, substitution versus integration by parts. And this is our test case, right from the textbook. It looks a little awkward, doesn't it? We've got this x multiplied by a bracket raised to the power of 7. Let's see how two totally different approaches can crack this nut. So we have Nadia, who decides to use substitution to simplify that tricky bracket. Then you have Richard, who sees a product of two different things and immediately thinks integration by parts. They're starting from completely different places. Let's follow Nadia's method first. She defines u as the inside of the bracket, which means the whole integral can be rewritten just in terms of u. And look at that. It turns into a simple polynomial that we can expand and integrate easily using the power rule. The only thing left is to sub back in for x at the very end. Now let's look at Richard's approach. He splits the problem into u and dv. Then he calculates du and v. From there, it's just a matter of plugging everything into the integration by parts formula. And notice how that leaves him with a much, much simpler integral to solve. It's a very systematic, step-by-step process. And here is the coolest part. If you look at Nadia's final answer and Richard's final answer, they don't look the same at all, but they are. They're algebraically identical. If you multiplied them both out, you'd get the exact same thing. And that's a huge lesson. There's often more than one right way to get to the answer. So if there are multiple methods, how on earth do you choose? Well, it all comes down to pattern recognition. You need to think of these techniques as tools in a toolkit, and your job is to spot the clues in the problem that tell you which tool to grab. So let's test that out. We're going to play a quick round of Spot the Technique. I'll show you an integral from the textbook, and you tell me what's the first method that pops into your head. Ready? All right, have a look at this first one. What do you see? It's a fraction, right? A polynomial on top and another one on the bottom. What's our classic strategy for a setup like this? If you were thinking partial fractions, you are absolutely right. That's the go-to move for breaking down a complicated fraction into simpler pieces that we can actually integrate. Spot on. Okay, next one. Here we have x, a simple polynomial being multiplied by a trig function, sine of 4x, a product of two totally different types of functions. What does that scream out to you? Yep, that is a textbook signal for integration by parts. It's literally designed to solve integrals that are a product of two functions, just like we saw with Richard's method. And for our final one, look really closely at the relationship between the top part, 3x squared, and the chunk inside the square root, x cubed plus 1. Do you see a connection there? And that's the big clue. 3x squared is the derivative of x cubed plus 1. When you spot a function and its derivative hanging out together in an integral, that is a massive flashing sign to use U substitution. It cleans these problems up beautifully.
Okay, awesome. You've got the basics down, you've seen the advanced techniques. Now let's bring it all home and build that exam confidence. We're going to run through some quick-fire questions to really nail down the most fundamental rules.
Here's the first one. A nice, straightforward polynomial, no hidden tricks, no complex stuff. What's our plan of attack? Simple. We just go through it piece by piece, term by term, and apply the power rule. For each term, add 1 to the power, then divide by that new power. And what's the one thing we never, ever, ever forget? That's right, add the plus c. Okay, one more, just to lock it into muscle memory. You'll see it's the exact same pattern, just different numbers. The process itself is identical. See? Exactly the same, simple, repeatable process. Term by term with the power rule, then slap on the plus c at the end. Once you get this down, you can fly through these kinds of questions. So let's tie it all together. Further integration is really all about mastering those basics, knowing your two big weapons, substitution and integration by parts, and then, most importantly, getting good at recognizing the patterns that tell you which weapon to use. And there's only one way to get there. Practice, practice, practice. You now have the tools to solve a whole new universe of problems. You've seen the methods, you know the strategies. The only question left is, what are you going to solve first?